Einstein was asked the big question, is there a God? Is there a meaning to everything, right?
Right.
And here's how Einstein answered the question. He said, there really are two kinds of gods. We have to be very scientific. We have to define what you mean by God. If God is the God of intervention, the personal God, the God of prayer, the God that parts the waters, then he had a hard time believing in that. Would God listen to all our prayers for a bicycle for Christmas and smite the Philistines for me, please?
Right.
He didn't think so. However, he believed in the God of order, harmony, beauty, simplicity, and elegance, the God of Spinoza. That's the God that he believed in because he thought the universe was so gorgeous. It didn't have to be that way. It could have been chaotic. It could have been ugly, messy. But here we have the fact that all the equations of physics can be placed on a simple sheet of paper.
Right.
Einstein's equation is only 1 inch long.
You see, Einstein's equations break down at the instant of the Big Bang and the center of a black hole. The two most interesting places in the universe are beyond our reach using Einstein's equations. We need a higher theory, and that's where string theory comes in. String theory takes you before the Big Bang, before Genesis itself.
Einstein wanted an equation that would unify gravity, the electromagnetic force, and the two nuclear forces. He wanted unification of all four forces into one theory, the theory of everything, the God equation.
When I was a child of 8, something happened which changed my life totally. A great scientist had just died, and all the papers flashed a picture of his desk with the unfinished manuscript of his greatest work. And I said to myself, wow, why couldn't he finish that? What's so hard? Why didn't he ask his mother? Well, I went to the library, and I found out this man's name was Albert Einstein. And that book was to be the God equation, an equation no more than 1 inch long that would allow us to, quote, read the mind of God.
To me, when we finally discover, quote, the God particle, this is just the beginning. It's going to open the floodgates for a whole new branch of theoretical physics. There are some eternal questions that cannot be answered in the framework of conventional physics. Is time travel possible? Are there gateways to other universes? Are there other dimensions? Are there parallel universes? Einstein's equations hint at higher dimensions. They hint at parallel universes. They hint at time travel. But to nail it to the wall, you have to have a theory of everything.
A few months ago, the headlines were dominated by the fact that physicists think they found the Higgs boson. Well, the media said, this is a great discovery, but what do you mean you think you found the Higgs boson? Well, to within 5 standard deviations, yes, we think we found the Higgs boson. And the media said, what do you mean by that? Well, I would have answered the question differently. I would have said, with 99.9999% confidence, we have bagged the Higgs boson. If you are an odds maker in Las Vegas, and the bets are that you are 99.9999% confident that you have it, then yes, you have it. The purpose of the Higgs boson is to break a symmetry. And when you break symmetries like the symmetry of the universe, then you get big bangs. So what is the Higgs boson? The Higgs boson is a fuse. It's a match. It's the spark that set off the Big Bang. It put the bang in the Big Bang. Let's say that our universe is a sheet of paper. We live our entire life on this sheet of paper, but directly above us, there could be a parallel universe hovering right over us, perhaps inches, centimeters away, and objects in this parallel universe would be invisible. Light travels beneath the universe, so we never see this other galaxy. But gravity goes between universes, because gravity is nothing but the bending of space. So if the space between two sheets of paper is bent slightly, gravity then moves across. So think about it. This other galaxy in another universe would be invisible, yet it would have mass. That's exactly what dark matter is.
When we physicists look in outer space for alien life, we don't look for little green men. We look for type 1, type 2, and type 3 civilizations. A Type 1 civilization has harnessed planetary power. They control earthquakes, the weather, volcanoes. They have cities on the ocean. Anything planetary, they control. That's Type 1. A Type 2 civilization is stellar. They've exhausted the power of a planet, and they get their energy directly from their mother star. They just don't get a suntan on a weekend. They use solar flares. They use the power of the sun itself to energize their huge machines. Eventually, they exhaust the power of a star, and they go galactic. They harness the power of billions of stars within a galaxy. Now, for example, Buck Rogers would correspond to a Type 1 civilization, a planetary civilization. Star Trek and the Federation of Planets, who have colonized a few star systems, would correspond to a Type 2 system. And the Empire of Star Wars would correspond to a Type 3 civilization. Now, what are we on this scale? We are Type 0.
Go to your dog tonight and teach your dog the meaning of tomorrow.
Yeah, not going to happen.
Teach your dog the meaning of tomorrow. Your dog can't do it. Animals live in the present for the most part, maybe a few hours in the future, but for the most part, animals live in the present. This part of the brain is a time machine. We are obsessed with the future. We daydream about it. We muse about it. We wonder, we plot, we scheme, everything in the front part of the brain. And that's what makes us different. Now, does IQ measure that? Not really. IQ measures some of that is bookkeeping, because that's what IQ exams are. Good for calculating bookkeeping. If you're an accountant, I imagine you do very well on IQ exams.
MRI scans show that memories and experiences are not found in just one spot, but are actually spread out over the entire surface of the brain in different combinations of our neurons. So when we daydream, these memories drift and begin to bump and interact with other memories. Eventually, out of these random collision of memories, an idea forms. Next, the brain runs simulations of these ideas into the future.
How big a breakthrough is this, and what could it really mean?
Well, this is a giant step toward the holy grail of energy research. To hit break-even, to extract more energy than you put in. And this could eventually become a game changer. You see, fusion reactor is carbon neutral. It does not create carbon dioxide. It does not create copious quantities of nuclear waste that you find in fission plants with uranium. It does not melt down. You cannot melt down a fusion reactor. And the fuel is seawater. Hydrogen from seawater could be the basic fuel. So this is too good to be true. And yet we've taken a giant step forward. This could be the energy source of the future.
We are born scientists. When we're born, we wonder what's out there. We begin to wonder about the sun, life, the stars, what makes the oceans, the weather. We're born scientists. And then something happens. When we hit the danger years of junior high school and high school, that's when it's literally crushed out of us.
Those are the worst.
Every little flower of curiosity, said Einstein, is crushed by society itself. Because we have to learn all these facts, figures, memorization. We think that memorization is science, and that's not true at all. My daughter had to take the Regents exam once, and she had to memorize all these facts and figures about minerals, crystals for a geology exam. Nowhere did I see the true driving force of geology, which is continental drift. That's the organizing principle for all of geology. And yet the exam was memorizing all the names of the crystals and the minerals. And then later she comes up to me and says, "Daddy, why would anyone want to become a scientist?" That was the most humiliating event in my entire life. I felt like taking that book and ripping it apart.
The information revolution has a weakness, and the weakness is precisely the educational system. The United States has the worst educational system known to science. Our graduates compete regularly at the level of third world countries. So how come the scientific establishment of the United States doesn't collapse? If we're producing a generation of dummies, if the stupid index of America keeps rising every year, just watch network television and reality shows, right? How come the scientific establishment of the United States doesn't collapse? Let me tell you something. Some of you may not know this. America has a secret weapon. That secret weapon is the H-1B. Without the H-1B, the scientific establishment of this country would collapse. Forget about Google. Forget about Silicon Valley. There would be no Silicon Valley without the H-1B. And you know what the H-1B is? It's the genius visa, okay? You realize that in the United States, 50% of all PhD candidates are foreign-born. At my system, one of the biggest in the United States, 100% of the PhD candidates are foreign-born. The United States is a magnet sucking up all the brains of the world, but now the brains are going back. Right. They're going back to China. They're going back to India. And people are saying, oh my God, there's a Silicon Valley in India now. Oh my God, there's a Silicon Valley in China. Duh. Where did it come from? It came from the United States. So don't tell me that science isn't the engine of prosperity. You remove the H-1B visa and you collapse the economy. In Wall Street Journal, editorialized against a congressman who wanted to ban the H-1B, saying they'll take jobs away from the American people. The Wall Street Journal said, look, there are no Americans who can take these jobs. These are at the highest level of high technology. They don't take away jobs from Americans. They create entire industries. And so that's why we have an Achilles heel, and that's the educational system. And again, sociology majors are not necessarily going to be the ones determining the future of Silicon Valley, but physicists, engineers, we need more of them, not less.